Thank you for the introduction. I'm Mizuhara from the University of Electro-Communications. I will talk about a combination of mechanical and electrical stimulation for intense and realistic tactile stimulation sensation. Haptics is very important for immersive experience of VR. For example, when we touch something in VR, we want to feel that touch sensation. On the other hand, we sometimes need very strong haptic sensation. For example, when we are being attacked by a game character or being shot by someone in VR game, we must give very strong sensation. At the same time, of course, it must be safe. So our question is as follows: how can we achieve intense, realistic, yet safe haptic sensation? There are few trials on presenting intense tactile stimulus, and this may be because intense stimulus may injure skin or may leave marks on the skin. For example, a pain station presents painful mechanical stimulus by whip as punishment during game. This is an intense tactile stimulation, but of course it leaves marks on skin stimulus by whip and cause injury. So the goal of this research is to present realistic and intense tactile feelings safely so as not to injure skin. There are two main methods for presenting tactile stimulation: physical deformation of the skin by mechanical stimulation, and or direct excitation of nerves such as electrical stimulation. Tactile stimulus by mechanical stimulation can present a natural tactile presentation because it reproduces the realistic mechanical interaction between skin and object. However, intense stimulation may carry a risk of injury. On the other hand, electrical stimulation excites sensory nerves via electric current. Intense tactile presentation is possible without damaging the skin. However, the naturalness of sensation is reduced compared with touching real objects. For example, electrical stimulation has bizarre sensation. We call it electrical sensation. In summary, mechanical and electrical stimulation methods have advantages and disadvantages. So our idea is that a combination of the two strategies may produce a realistic and intense tactile sensation. Ideally, realistic tactile feeling could be elicited by a mechanical stimulation with sufficient tactile intensity achieved by electrical stimulation. We developed the haptic presentation device that combined electrical and mechanical stimulation and verified whether subjective intensity could be enhanced via electrical stimulation and whether electrical sensation could be decreased by mechanical stimulation. The device for the mechanical stimulation consists of a mechanical tactile device similar to a guillotine. The mechanical stimulation device has a 3 mm thick wood board, 36.5 gram weight that fell vertically. Two photoreflectors were attached to the frame in order to detect the speed of the falling wood board, and electrical stimulation could be presented simultaneously. Electrical stimulus is presented by electrode on participant's arm. Large anode and line cathode were used. In general, nerves around cathode are activated. First, we put the electrode on participant's arm, then participant put his arm under the apparatus. In each trial, we first present the reference stimulus and then comparison stimulus. And participants were asked to state the subjective intensity of the comparison stimulus, assuming that of the reference stimulus was 10. and how strongly they felt the electrical sensation on the 7-step Likert scale, which 1 indicates no electrical stimulation and 7 indicates nothing but electrical stimulation. The reference stimulus was mechanical stimulus from a height of 4 centimeters, and the following 4 conditions were used for comparison stimuli. Mechanical stimulus from a height of 4 centimeters, same as reference stimulus M4, and mechanical stimulus from a 6 centimeter M6, and electrical stimulus E, and mechanical stimulus from a height of 4 centimeters with electrical stimulus E plus M4 condition. Each stimulus was presented once in an order determined using a Latin square. Then how much will be the subjective intensity under each condition, assuming that a subjective intensity of reference stimulus is 10. According to a preliminary experiment, E plus M4 condition has the same intensity as M6. In addition, M6 is expected to have 1.5 times higher intensity than that of the reference stimulus M4, because M6 has 1.5 times higher potential energy. Then theoretically, intensity of E only will be 5. As for electrical sensation, it is expected that mechanical stimulus decreases electrical sensation. This is the result. This figure shows the subjective intensity under each stimulation conditions. The most important result is E plus M4 stimulus was perceived stronger than M4 only stimulus, significantly. On average, the subjective intensity was increased 10 to 12.5. However, the gain is less than expected. And if mechanical intensity was expected to increase to 10 to 15. There is the possibility that there is a group in which the sensation is enhanced by electrical stimulation, and a group in which it is not. So it is necessary to conduct further experiments on the effectiveness of the combining stimulations. This figure shows the electrical sensation under each stimulation condition. All participants reported that the E plus M4 stimulus was weaker than E only stimulus. So, as we anticipated, the mechanical stimulus reduced the sensation of electrical stimulus. We demonstrated a haptic presentation method which combines